Welcome, everybody. In this series now, we start looking at concentration calculations, basic calculations regarding some concentration units, getting you used to the idea of molarity and how these equations and so forth work. So in our example, we were looking at the salt copper 2 nitrate trihydrate. You can see here at the top right, copper 2 nitrate trihydrate. That's what it is. So, in our first question, we have A, and it says if 4 mole of copper 2 nitrate trihydrate must be dissolved to make a 500 milliliter of a solution, determine the concentration in molarity of the salt in the solution. Well, we need essentially the number of moles and the volume of the solution, and that then gives us the concentration. So the concentration of the copper salt is equal to the number of moles of the copper salt divided by the volume of the solution. And that is 4.0 mole divided by the 500 milliliters, so 500 times 10 to the power minus 3 liter. You will get a value of 8 mole per liter, which is commonly known as 8 molar. All right, so that is the concentration of this solution. We move on to the B question. The B question says, consider 250 milliliter of a 1.5 molar solution of copper nitrate. Determine the molarities of the ions present in the solution. Now, where we need to start is that copper 2 nitrate means that you have an NO3. There's 2 ions there, which has been solvated. So there's 3 waters, and they have been solvated in water to give copper 2 plus in aqueous form, as well as 2 nitrate anions in aqueous form, as well as water, 3H2O, liquid that has been lost. So that means the number of moles of the copper nitrate clan is equal to the number of the concentration multiplied the solution volume, which is 1.50 mole per liter, multiplied by 250.00 times 10 to the power negative 3 liter, end up with 0.375 mole copper nitrate 2. Alright, so that means number of mole of copper 2 plus that comes from this is going to be directly that mole copper 2 plus. Right, so the number of mole of the nitrate 3 minus that come from this is going to be twice that. So it's 0.75 mole nitrate. Why? Because there's 2 nitrates that come from every 1 mole of copper nitrate trihydrate. Okay, and this is now in the solution described is 250 milliliter solution determines molarity of the ions is in 250 milliliter solution. So therefore, the concentration of the copper 2 plus is equal to the number of moles, 0.37375 mole per liter. So is 250.00 times 10 to the power minus 3 liter, giving us 1.5 molar. Right? And the same for the nitrate, equaling, but now 0.750 mole, the same amount of 250.00 times 10 to the power minus 3 liter is equal to 3.0 molar. You just compare those values then and compare them to the concentration of copper, pure copper nitrate in solution. You'll notice that it is double in one case and the same in another. And why is that? It's because you only get one ion and the other ion split into two. Right, and that was it. We can move on to question C. Question C asks for, consider a 250 mol solution that contains 59.6 copper nitrate trihydrate. Determine the molarities of all the ions in solution. Well, first we need to start by calculating the number of moles of the copper nitrate trihydrate. That would be the mass divided by the molar mass. Mass is the 56 or the 59.60 gram, and the molar mass is 241.61 gram per mole. Why? Because it includes the water. Gives us a grand total of 0.247 mole copper nitrate trihydrate. Okay, so that means that the number of moles of pure copper, 2 plus copper, is going to be equal to the number of moles of the copper nitrate trihydrate and the number of moles of the nitrate going to be equal to 2 times the number of moles of the copper nitrate. Okay. Oops. This is equal to 0.247 mole. This is equal to 0.494 mole. From this, we can calculate the concentrations. Concentration of copper 2 plus is this number of moles divided by the volume, give you a value of 0.988 molar. Concentration of NO3 minus is equal to 1.98 molar. Okay, and that's it for the C part. The final part is D, and in D it asks us, solution of this copper trihydrate is available in experiment, so much millimoles is required, what volume should be used? So we have a situation where we need 0.760 times 10 to the power negative 3 mole copper NO3 2 is required. Right. So the concentration that we have is 0.038 mole per liter. So hence, if we divide those two values, it will give us the volume needed. V needed is going to be equal to 0.760 times 10 to the power minus 3 mole divided by 0.038 mole per liter is going to give us a value of 0.02 liter rounded 20 milliliter of solution. 20 milliliter of solution will contain that many mole of copper nitrate for whatever experiment needs to be conducted. All right, I think that's kind of straightforward, very little manipulation, but just go to mole, go to volume, go to concentration, kind of calculations. All right, thank you for watching, and I'll see you in the next video.